recording or not. Just keep it rolling because we've got plenty on there. I think we've got 8 gigabytes in there. Hello, today we're going to be going over the different uses for reverse osmosis and how it works. Now, with any filtration that you are going to be doing, you need to first start off with the pre-filtration unit for the system. This is a large pre-filtration unit that will handle up to about 80 gallons a minute flow rate. And that's to work with this 50,000 gallon a day reverse osmosis system. So this system is going to Africa for a water bagging plant. So what would happen is they would have a well at the site, and the water would go into a big water storage tank. From the water storage tank, the water would enter into this pump to create water pressure to flow through the system. So from there, then it would go up to the pre-filtration, which would actually be your first filtration step. Sometimes you only have one of these, sometimes you'll have two. One, maybe you always need carbon filtration, because carbon filtration is very important to take out volatile organics, chlorine, many other harmful pesticides, heavy metal, that sort of thing. Now, if you have a lot of biological, like algae in the water, you would need another one of these, which most people consider a multimedia filter. So after the water would be pre-filtered through your pre-filtration, it would then go in through your final pre-filters. Now these are two 5-micron pre-filters, which will remove down small enough that it will go through the membrane. The water goes through the membrane without clogging the membrane. From there, the water goes into a high pressure pump, which looks similar to this pump, but it's back there where you really can't see it. The high pressure pump then pumps water up into the membranes. You can see the white spot over on the other side, the white pipes. The water comes in, so it feeds in this side, and then feeds this side. And the gray tubing here is where the purified water comes out. The purified water will then go up to the flow meter here that tells you how many gallons or liters per minute you are producing. Now with reverse osmosis, it typically takes 2 gallons to make 1 gallon. That is because you have to take the contaminants that are in the water and take them away from the membrane to keep the membrane from getting clogged up, because it is a very fine filter. So this tells you how to balance the system. So in other words, what you want to do is have these two floats in here at the same level. Now the floats are controlled by how much water is going to the drain through the valves here. So you would turn this until you got these balanced. Now you want to have a certain amount of pressure on the membranes. Some membranes are made to run at, say, 100 psi, where others are made to run up to, say, 200 for standard reverse osmosis. Now for a saltwater system like a DIALS or desalination plant, you would like to have a lot more pressure. Most of them run between 800 and 1200 psi. So to adjust your water pressure, you turn this valve and you'll see the pressure change on the gauge here. So you can adjust your pressure. This system is made to run at about 125 psi. Now, as mentioned before, we have pre-filters on here. Now, when these pre-filters get dirty, the flow stops going down and you can get a pressure drop. So this gauge tells you the pre-filter pressure going into the filter, and this tells you going out. So when you have an 8 to 10 pound pressure drop, you know it's time to change those pre-filters. Then again, you've got your system pressure, and after the water leaves the flow meter here, then the water would go into a pure water storage tank. That's where the water is stored, because and you pull it out on demand. Now, we've pre-filled the water over on this side. We purified basically with the center section. Now over on this side, we have the delivery section. So what would happen is you'd hook up a pipe right here from your water storage tank. That would pump in and work with a pressure tank. You need to have a pressure tank to keep the pump from cycling on, off all the time. From there, the water would go up, and you can't really see too well from here, but there's dual post-carbon filters. Post-carbon filters will take out any final odors you may have picked up while in the tank. A lot of people will just call it a polishing filter. From there, the water goes to ultraviolet sterilizer, which will kill any bacterial matter in the water. It's 99.9% effective on any biologicals and disinfection. Then the water would go out to whatever filler you're using. Now, a system like this would be good for a bottling plant. A lot of people use them for water bagging plants. They can be used for hotels, hospitals, anywhere where they would need a large amount of water purified. Now, we do make systems starting off basically at 100 gallons per day, all the way up to 125,000 gallons per day. So depending on the use, we can design a system for your use. One other thing we do have is we do a lot of custom systems. In fact, right over here, we have a custom system that we're building actually to clean the membranes, but it works very similar to the reverse osmosis. You can have pre-filtration of this. It would come in through a pre-filter, which would go to a pump, go through the membranes, and then into the water storage tank. So this unit actually could easily be converted, besides for cleaning the membranes, into a system that would actually produce water, but without the delivery system. Now, a lot of companies will sell just an RO part. Now, this is just the RO without the pre-treatment and the delivery system. So, whenever you're thinking about doing a water project, you need to make sure you're getting everything you need as a complete system. Now, getting back over to this system, it all comes pre-wired. In the back, we have an electrical panel, and we'll turn around the system and show you how that works. Let's cut it. Cut. Just go ahead and turn it on.
It's on.
And I'll see when the light goes on yours. Here we have the back of the reverse osmosis system. A lot of people won't really show you a whole lot about what's going on these. Again, we have where the water comes into the system, flows up through the dual pre-filters, into the RO pump, then out to the membranes. Once it goes through the membranes, you've got connections up here and here for the water that would go into the tank and for the wastewater. Again, we showed you the pump over there where the connection is on that, so you really don't need to see it from there. But that's the pump that delivers the water to whatever type of use you're using, the filler or whatever. We're using a dual UV system and a dual carbon on the system. That way you also have a backup in case it failed. But the main reason is the flow rate. Everything has to be sized properly to work together. If you're producing, say, 25 gallons a minute and you can only deliver 12, then your system's not going to work properly. It has to be sized correctly. Now, what we do here is this, since it's a complete system, we have an electrical panel right here with circuit breakers. So the first set of breakers would operate the feed pump, which would automatically be switched on through this box and a pressure switch to keep the pressure where it needs to be. The second box here is actually for the delivery pump, just on and off. And we got circuit breakers for running the RO part of it, and then a circuit breaker for the plugs. Now, the other thing that you could not see from the front of it is the pump here, which is chemical injection. Now, if you have, say, silicon in the water, which is probably the biggest problem with plugging up reverse osmosis membranes, you run a chemical and it injects into the water here to keep the membranes from becoming clogged. It's very important to use this on any big system. Well, I think that about covers it all.